Okay, welcome to 5.3. We're going to use angle bisectors. We've seen angle bisectors before, but now we're going to see how it relates to triangles. Remember that an angle bisector is a ray that divides an angle into two congruent adjacent angles. So I'll remind you, here we have an angle. If we draw an angle bisector, what the angle bisector does is that it splits the angle into two congruent parts. These congruent parts are adjacent, meaning they share a vertex and they share a ray. These angles are right next to each other and they're congruent because the angle bisector splits them in half. Also remember that the distance from a point to a line is the length of the perpendicular segment from the point to the line. Now, what we mean by that is, if you have a line and a point, the shortest distance from this point to the line is a straight line that is perpendicular. There's no other line that will be shorter. If you draw another line, this slanted line is actually longer. This line is longer. The shortest line from this point to this horizontal line is a vertical straight line that is perpendicular. So when you think of distance in angles or triangles, always think of the perpendicular segment. In this diagram to the right, ray PS is the bisector of angle QPR. And the distance from S to PQ is SQ. See how this is perpendicular? The distance from this whole entire ray to this ray is this distance right here. Okay. And likewise on the other side, segment PR, the distance from PS to PR is segment SR. Now let's see how we're going to use these angle bisectors. First, I'll introduce angle bisector theorem. This theorem has a hypothesis and a conclusion like every other theorem. Let's read the hypothesis first. If a point is on the bisector of an angle, so for example here to the right we have a bisector AD, D is on the bisector. So if we have a point on the bisector, then it is equidistant, in other words congruent, from the two sides of the angle. So since D is on the angle bisector, it is at an equal distance to C and to B. So this distance right here is congruent to this distance, since it's on the angle bisector. So if we were to have any angle and you have a bisector, let's say this that bisector split the angle into two parts, and you have a point M, the perpendicular length segment from M to the side of the angle is congruent to the other perpendicular segment. So not only are the angles congruent, these sides are congruent. The converse of that theorem would just be saying it in reverse. If a point is on the interior of an angle, so let's say we have D, it's in the angle. We don't know if there's a bisector yet, but there's a clue. Since DC is congruent to DB, there must be a perpendicular bisector. So here there's a perpendicular bisector. And I'm sorry, there is a angle bisector. So if a point is in the interior of an angle and is equidistant from the sides of the angle, then it lies on the bisector. So it would kind of be like this. If you have an angle and then they tell you this point here, P. We don't know if P is on the bisector. All we know is that P is the distance from P to this side of the angle is perpendicular. And this one's also perpendicular. And this is congruent to this. Because these two segments are congruent, we know that there must be a bisector going through P. Now let's use this theorem. Here it says find the measure of angle GFJ. So GFJ is right here. Now, We don't know if this is an angle bisector really. There's no congruent arcs here, but all we know is that the distance from J to G is 7 and the distance from J to H is 7, same distance. And these are perpendicular segments. So that means that by the converse of the angle bisector theorem, that this must be an angle bisector. So if this is an angle bisector, that means this angle is congruent to this angle. So the missing angle we're looking for is also 42 degrees. Let's read that proof in paragraph 1. Because JG is perpendicular to FG, and JH is perpendicular to FH, and JG equals JH, which is 7, ray FJ bisects angle GFH by the converse of the angle bisector theorem. So the missing angle is 42 also. So for example, if you have an angle like this, and you have a ray going through it, and let's say this is 10, and this is also 10, because these segments are congruent, the angles here must also be congruent. So if this is 30 degrees, this one would also have to be 30 degrees. Because these segments are congruent, then the angles also have to be congruent. Okay, let's see how this applies to some real-world examples. A soccer goalie's position relative to the ball and goalpost forms congruent angles, as shown. Will the goalie have to move farther to block a shot toward the right goalpost R or the left goalpost? So if you notice here, it's a giant angle, angle LBR. Then there's a ray coming out of B to the goalie. That's kind of like the angle bisector because it created two congruent angles. So because this is an angle bisector, if we draw a line going straight from the angle bisector to the goalpost, it's a 90-degree angle. This also forms a 90-degree angle. So that means he'll have to move an equal distance to both sides. There's not one side that's farther. Because these angles are congruent, these segments are also going to be congruent. So the goalie must move the same distance to block either shot. So because these angles are congruent, these distances are congruent. For what value of x does P lie on the bisector? Okay. So we want to know if P is on the bisector. Well, for P to be on a bisector, these two would have to be congruent. So you have to set x plus 3 equal to 2x minus 1 and solve for x. So let's check out the solution. From the converse of the angle bisectors theorem, you'd have to set them equal to each other. You move the x over and the 1 over, and you get x equals 4. Perfect. Let's try these exercises together. So here, because these are congruent, these have to be congruent. So x also equals 15. Here, because these segments are congruent, these angles have to be congruent. So you have to do 3x plus 5 equal to 4x minus 6. And I'll leave it up to you to solve for x. Here you have to do 5x equals 6x minus 5. Here it says, do you have enough information to conclude that QS bisects angle PQR? Explain. Okay, here, even though these are congruent, what's missing is the right angle symbol. Since these cannot be right angles, you can tell that it's acute, then these are not the perpendicular segments. So we cannot conclude that these angles are congruent. So we do not have enough information. We're missing the right angle symbol. Okay, that's it for part 1 of use angle bisection.